Okay, the next thing I'd like to mention is I'm not going to cover in these lectures the characteristics of molecular compounds. However, I would like you to read over that in the book. Now, let's move forward and talk about molecular compounds and Lewis structures. So this next one is going to be Lewis structures of molecular compounds. We're talking about Lewis structures of molecular compounds. Now, to start with, of course, that means that what we should mention is this definition of the word a molecule. Okay. Now, a molecule is a compound, of course, made of atoms and held together by covalent bonds. Now, this is distinctly different from ionic compounds, because remember, ionic compounds are held together by ionic bonds, which are electrostatics, positive and negative charges held together tightly. In contrast, molecules are discrete individual units. Okay, these can be seen as individual particles. Remember that ionic compounds don't exist as individual small particles. They will just be however many positive and negative ions are associated into the larger structure. That's why we have formula units for ionic compounds. And when it comes to molecular compounds, we can have, of course, a molecular formula. The molecular formula will be the precise number of atoms within a single molecule of the molecular compound. Okay. So it'll be the precise number of atoms of each element in that molecular compound. So how do we form these Lewis structures? Well, let's define a couple of other things before we do that. Let's mention, of course, that a single line is what we will use for a single bond. A double line, as we've mentioned before, double bond. Triple line, that'll be your triple bond. We should also mention that a dot dot like that, a pair of electrons on a side of an atom with no other atoms, that's going to be our lone pair. And of course, you should have read about lone pairs at this point, but let's just briefly mention what are lone pairs. Well, we can view lone pairs as pairs of non-bonded electrons in a full orbital. So you have a pair of electrons that exist in a valence orbital of an atom that are not involved in the bond. Okay, so the general approach, and this will have also been outlined in your book, the general approach to molecular Lewis structures can be done as follows. One, generally what we do is find the total number of the valence electrons in the molecule. And we can do this for polyatomic ions as well. So we'll say also for polyatomic ions. Okay, which means a couple of additional notes here. Cations lose a number of electrons equal to the positive charge. So you'll count out the total number of valence electrons expected with each atom in that molecule, and then subtract off that number of electrons equal to the positive charge. By that same token, anions, of course, we know gain electrons, and so it will be equal to the negative charge of that particular ion. So you'll count up the full number of valence electrons associated with each atom in that molecule, and then add an additional number of electrons equal to that charge. Finally, of course, recall that compounds, by definition, are neutral. And so for compounds, unlike the ions that we just mentioned, you do not add an additional number of electrons. Compounds contain the number of electrons equal to the number of electrons found total of all the atoms present. Okay. Step 2, of course, draw single bonds between the atoms. At this point, you should have determined the central atom. The general trend with that tends to be something we'll discuss later this lecture. Okay, so you put your atom, whatever is your central atom, in the center. And we'll say that a central atom is one that connects to two or more other atoms. 3, place any remaining valence electrons. So take those remaining valence electrons that are not accounted for in the single bonds you've drawn, the remaining valence electrons, around on the outer atoms. So the outer atoms first, you place electrons first on the outer atoms. Then, if there are still any remaining electrons, those remaining electrons are then placed on the central atom. So you fill outside in, pair of electrons onto each atom. From there, if the central atom does not yet have an octet, we look at how we can fulfill that octet. Okay, so step 5, we could say, look at your central atom for an octet. If it's got an octet, cool. If it needs an octet, then generally you would form a double bond to atoms with lone pairs. And this will become more clear when we do a bunch of examples of these Lewis structures. Okay. There are additional notes that your book makes actually before looking at the general rules, and I wanted to look at that in the opposite direction. So your book says, what about Lewis structures first with carbon, nitrogen, oxygen, halogens, or hydrogen? So what about them? We'll answer these questions in the next recording.